Hello. In this video, we're going to be using our trig to solve real-world application problems. And so what we're looking at in the first problem is something to do with aviation. Now some aviators, people who fly, need to know the cloud ceiling before flying to determine at what altitude they're allowed to do the flying. So one way this is measured is by sending a light beam straight upward to the clouds, while a nearby measurement device is used to find where the light disappears into the cloud deck. If the measurement device is 1,000 feet from the beam and records an angle of elevation to the cloud of 84 degrees, what is the cloud ceiling? So let's draw a picture of this. So here's the ground, and we have a beam of light going straight upward from that spot. So in theory, this should be a right angle if it's truly measured correctly. Now over at this place we have a measurement device 1,000 feet away from the light beam. And that measurement device is meant to figure out where the light beam and the cloud intersect, or rather where the light beam disappears into the clouds. And we know that that thing has measured an angle of 84 degrees. And we want to find the height right there, x, we'll call it, from the ground to the clouds. So this is where our trig comes into play. We know one side, we know an angle, we want to find a missing side. Well, we want the opposite, we have the adjacent, so that means we're going to be using tangent. So tangent of the angle 84 equals, tangent is opposite over adjacent, so our opposite side over the adjacent side. And our goal now is get x by itself. We'll multiply both sides by 1,000. These will cancel, and so x will equal whatever 1,000 times tangent of 84 is, which ends up being 9,514.4 feet. So this would actually be in the mid-range level of clouds. Okay, and so that's one application of trig in this situation. In number 2, in Dubuque, the Fenelon Place elevator, also sometimes referred to as the 4th Street elevator, claims to be the shortest, steepest, scenic railway in the world. The railway itself is measured at 296 feet in length and raises passengers 189 feet from 4th Street below. What is the angle of incline for this elevator that we can perhaps refer to it as the steepest? So let's draw the picture. So here is the cliffside that it's going up, and then here is the incline, the elevator itself, the path that it would follow. And so here's the distance that it would be from that cliffside. And so we know that it is 296 feet in length and raises passengers 189 feet off the ground. And what we want to find is the angle of incline. So we're finding x right there. So again, this is where trig comes into play. We know from angle x, we know the opposite side, we know the hypotenuse, which means we're going to use sine. The sine of our angle x is the same as the opposite, 189, over the hypotenuse, 296. To find x, we do our inverse. Anytime we want to find angle, we do an inverse. So x is going to equal the inverse sine of 189 divided by 296. We'll plug that into our calculators and we'll get x is approximately 39.7 degrees. The angle of incline would be 39.7 degrees. So we've seen two examples of how trig can help us understand or figure out some problems. So for now we are done.